So the next topic is lecture number 15. You're watching this video on my YouTube platform, Govind Chemistry, and this side your chemistry mentor, Govind sir. So the topic is Gibbs free energy. The Gibbs, he's a foreign scientist. Why it is not like Sati's free energy, Govind free energy? Because we don't have such type of invention, but I hope you people will do. Then your name also will be published. So what is the meaning of Gibbs free energy, children? So that is the only way, you can say, it's a lost, not lost, last way to determine the process is spontaneous or non-spontaneous. That is the last way to define spontaneity. We discussed 2 point enthalpy. Remember, delta H value negative. That means exothermic reactant to product. If energy released, then process is spontaneous, but here drawbacks available. Drawbacks like some endothermic reaction also spontaneous. Then we discussed entropy. Delta S positive, randomness increases, then process will be spontaneous. That here also some drawbacks. So these are not 100% correct method to determine the process is spontaneous or non-spontaneous. Then we have to go through Gibbs free energy. What is Gibbs free energy, children? Gibbs free energy, G is equal to H minus Ts. Okay, here H is enthalpy, T is temperature in Kelvin, and S is entropy. So G, Gibbs free energy, is a state function, so we cannot calculate it. We can calculate delta G, G final minus G initial. And for cyclic process, delta G value will be 0. All state functions for cyclic process, their value is 0. So in that case, delta G is equal to delta H T delta S. If constant pressure and constant temperature applied, then this formula will come. Delta G is equal to delta H minus T delta S. This equation is called Gibbs Helmholtz function. So children, change in Gibbs free energy delta G is equal to minus of useful work of system. Suppose delta G is 100 kilojoule. That means W useful is equal to plus 100 kilojoule. That means system can perform 100 kilojoule work if it is given delta G is equal to plus 50 kilojoule, then W useful minus 50 kilojoule. That means to develop the system give 50 kilojoule energy. That means if it is like that, then process is non spontaneous, and if it is like that, then process is spontaneous. Okay. Now we will check the condition. Delta H, delta S and delta G. What is the favorable condition, children, for delta H? If delta H is negative, then process is spontaneous, and favorable condition for entropy positive, then what? Delta G is equal to delta H minus T delta S minus T positive, then plus minus minus, then overall minus. That means it is the condition for a spontaneous process. Now non-favorable condition for enthalpy. If positive, non-favorable condition for entropy negative. So delta G delta H minus T delta S positive negative, so overall positive. So that is condition for non-spontaneous. Now one favorable and one non-favorable. Then what is, there are two conditions, delta G is equal to T delta S for spontaneous and for non-spontaneous. Delta G is less than 0, that means delta H T delta S should be less than 0. T delta S is greater than delta H, so T is equal to delta H upon delta S. If the value of temperature greater than delta H upon delta S, then it will be a spontaneous process. For non-spontaneous process, delta G is greater than 0. So these are the two conditions. You can reverse the condition also. This time this non-favorable positive and favorable non-favorable negative, sorry, and it is positive. Like that you can calculate. For equilibrium children, delta G will be 0. Okay. So if delta basically depends upon delta G value. Now check the question. A to B plus C, delta H is 30 kilojoule. Find temperature which this reaction is spontaneous. So delta H is equal to delta G is equal to so for spontaneous delta G should be less than 0. Delta H, put the value kilojoule and it is in joule given. So 3 into 10 की power 3 converted into joule minus 60. So T is greater than If temperature is greater than 500 degrees Celsius, on that temperature, this process will be spontaneous. For the given reaction, the heat of the reaction is exothermic. Which condition favor the forward reaction? Options are given: temperature high, temperature low, temperature is moderate, no effect of temperature. So exothermic is given, that means delta H is negative and delta S randomness increases. One thing you have to remember, note delta H is negative, then find delta S. Wait 1 minute. So delta G is equal to delta H T delta S negative, this is also negative, so negative positive, it will be negative. Exothermic reaction is what? Energy released. So delta S also negative. The heat of reaction is exothermic. So note, remember, exothermic means what? Low temperature. Endothermic, high temperature, remember always. So exothermic means low temperature. Second option will be correct. Coupling reaction. Delta G is equal to 100 kilojoule per mole and C2D plus 80 kilojoule per mole. So it is spontaneous and it is non-spontaneous. Coupling, that means if you will add this, then 8 plus C, B plus D. So G total is what? Minus 20, 100 minus 80 plus minus 20 kilojoule per mole. So this reaction will be spontaneous. That is called coupling reaction. So that is completed. I hope that relation also here we will covered. In the next video we will cover. So this is all about the Gibbs free energy, children. In the last video, that was the last video, next video will be the last video of the chapter. There we will discuss about the relation between equilibrium constant and Gibbs free energy. Thank you.